As we mentioned in a PowerPoint presentation, our road to understanding n of d1, n of d2, and the Black-Scholes formula is through a Monte Carlo simulator. And again, as I said earlier, while the Black-Scholes formula is a closed-form formula, the only reason why we're doing this simulation is to build a better intuition of how the formula is put together and what do the two probabilities, n of d1 and n of d2, mean. So the sheet that you see in front of you is basically a Monte Carlo simulator, and it has three clear and distinct pieces. Let's go through each of these pieces one by one. The first piece that you see from here, there you go. So where it says spot, strike, volatility, time to maturity, risk-free rate, n and delta t, these are the inputs to the model. They define what is the underlying process that we're trying to model. So in this specific case, we're trying to calculate the value of a European call option that is struck on a security at a strike price of 10. The current spot price is 9. The volatility of the security is 10%. The time to maturity of the call option is 1 year. The risk-free rate is set at 1%. N is the number of time steps that we use in a simulator, and delta t is the size of a given time step. So far so good. Now, so using these inputs, the model generates a handful of values. So if you see ST, this is the final value of ST. This is the final value of the underlying security at time t, at maturity. And this final value, we'll just take a look at where this final value comes through a little later. But this final value is the value that we use in calculating the payoff of the underlying option. If you remember, the payoff of an underlying option, of a European call option, is ST minus x comma 0. This is that ST. Now the second output that comes out from a model for a given simulation is what we call the logical test. And that logical test is ST greater than x. So in this case, the strike price is set at 10. The ST value that we've generated from a model is 7.86, and you can clearly see that this is not true, and hence the value is 0. Immediately after this, you have two additional pieces or two additional expectations. The first expectation is, what is the expected value of ST? So if I look at this distribution, if I work with these numbers, if I work with this input, if I apply the Black-Scholes simulator on this, at the end, what is the most likely value for ST? And this is a completely unconditional probability. All I'm saying is, if I run through my simulator, what's the likely value of ST that I'm going to see? The likely value for ST is 9.19. The second expectation is expectation of ST given ST is greater than X. Now, when I say given ST is greater than X, we're saying if I walk through the simulator, if I walk through the numbers, if I walk through the values, I am only interested in a subset that is represented by cases where the final value of your simulated path, the final value of ST, was actually greater than X. And that number, as you can see here, is 10.32 and is greater than E of ST. Then we have three quick values. We have a minimum ST. So what's the lowest value that we see? A maximum ST and an average ST. All of these values are basically coming from this price path. So if I scroll down, you can see that using that model above, I have simple path generating simulation that throws out a path of 51 steps. These 51 steps give me the range of values that I want to see. And every time you update the sheet, these values and this path will change. So from a modeling point of view, the first piece of a model takes care of the input, generates some basic output based on the path that we've generated in column D. So that's step one, that's part one of the model. Now the second part of a model is where we store the results. So the green line that you see here, when I say results, I actually have a number of calculations that we'll come back to when we start playing with the model again. Where do these results come from? If you look at the structure, the way the model is structured is that on part A, this piece, where we take the input and the basic output, where we generate the price path. In part A, we generate a price path and we have some basic results. Those basic results are primarily the value of ST. From the value of ST, I simply go out and calculate the value of the call option at that point in time for that iteration, and that is simply max of ST minus X comma 0. Now you can see here's the result of the price path. So whatever we're simulating is being represented here, and now every time I update the model, this price path changes. When this price path changes, what the model basically does is that it calculates some basic values. What are those basic values? It calculates ST. It calculates whether the logical test ST is greater than X is true or not. It calculates what is or what should be the value of ST if ST is greater than X, and it calculates the value of a call premium. So for all four pieces, the way the model works is I update the model, the price path gets updated, the results get calculated, the results get stored. And if you come to the last and final piece of our model, which is here on the right hand side, you can see that I call this my result warehouse. And what I'm doing is that for each iteration that my Monte Carlo simulator runs, I've gone out and dumped the values here. So for the interest of simplicity, I've limited the number of iterations to about 30. In our earlier videos, we've looked at how the sheet has been put together and what do the numbers on this sheet represent. In this session, we'll see how do we run the Monte Carlo simulator and what kind of results do we generate. Just as a quick review, if you've just joined us, what we have in front of us is a Monte Carlo simulator that has three pieces. The first piece generates a path based on, there you go. First piece generates a path based on the input that you see. So we use 1, 2, 3, 4, 5, 6, 7 elements as our primary input. Using these elements, we generate a price path. In this specific case, we generate a price path that is all of 51 steps, and that price path is reflected here in front of us. Once we generate the price path, we calculate some basic numbers. We store those numbers in what we call a results warehouse, and then we use this to calculate the value of a call option using both the Monte Carlo simulation method and an indirect implementation of the Black-Scholes method on the same Monte Carlo simulator. Now, generally in Excel, you can simply, once you build this model, in Excel you can simply press F9 and the model works. However, since I'm recording this session and the tool that I use to record this session has a small limitation in the sense that I actually have to manually update the cell. So if I press 1 here, you will see that the numbers here will change, the path here will change, this graph here will change, these results will change, and this will change. Okay. One sec, let me just change the settings of the screen so that we can see this better. Let me go to full screen. There we go. So now we have the entire screen in front of us. Change. There you go. So we have the entire screen in front of us. I'm just going to press 1. When I press 1, you will see changes happening here, here, and here. There we go. So what has just happened is, when I pressed 1, Excel triggered the update on this cell. When it triggered the update on this cell, all the random numbers here and here were updated. The price path was updated. This graph was updated. And then based on the tool that I'm using on this side to store the results of my Monte Carlo simulation, all the values for 30 iterations were first run and then stored. Press it one more time. You can see every time I press 1 and update it, these cells get updated. So what's happening in essence here is that when you press the update function, cell gets triggered, model gets updated, random numbers get changed, path gets changed, price path gets changed, the iteration gets run, the results get stored for 30 iterations, and the sample answers get calculated. This, in essence, is the primary function of a Monte Carlo simulator. As I mentioned earlier, you don't have to press 1 in Excel if you're doing this at home. All you need to do is press F9 or the calculation or the equivalent calculation key in the tool that you use, and the numbers will change. This video has been brought to you by financetrainingcourse.com. For a number of additional similar courses, training materials in PDF file format, sample Excel files, and models, please see financetrainingcourse.com. Thank you.